Hi, my name's Romeo Bruni, and today we're going to create a universe very quickly using a simple model that I think explains everything. We're going to start with a concept that Albert Einstein first showed. This is a diagram that he used in his famous 1927 lecture at the Prussian Academy of Science called Geometry and Experience, where he described a spherically shaped universe with light wrapping back on itself. And I think Einstein had it absolutely right. And I'm going to show you the theory right here. The general theory has only two things in it: energy and momentum. When the universe was created, it had a huge amount of energy, all of the energy in the universe, which includes all of what we typically think of energy, and of course all the matter, because matter is essentially just condensed energy. So energy includes everything. The energy was created, it was blasted apart. The blast creates a spherical orientation like a planetary nebula, which is an exploding star. This rapid accelerating sphere is the universe. The amount of energy, because it's rapidly expanding, is thinning. The dark energy is just the momentum of the Big Bang imparted. The thinning of the energy band is what is weakening the universe, if you will, fueling the expansion. Let's look at the universe when it was a baby. We can actually take a picture of the universe when it was a baby. We can take a picture of the universe when it was only 380,000 years old. To take that picture, we look everywhere in the sky, which is a paradox because you always look back to the baby, but we'll get back to that. By looking everywhere in the sky, and then you map it, you actually produce a globe. Now, this is a flat representation of a globe, but you're actually seeing a globe. That's the actual baby universe you're seeing. When it's 380,000 years old, it's already 10 times 10 to the 6th. That's 10 million light years across. So get that through your head. 400,000 years old, yet already 10 million light years across. That's because this front, this explosion, is moving at literally 3 to 10 times the speed of light. The universe is expanding that fast. This expansion is carrying everything with it, because everything in here, because it's all expanding rapidly but at the same rate, it's essentially a huge inertial frame of reference. What that means is that, for example, we're circling around the solar system, but we don't feel it because everything is circling around at the same speed. We're going around the Milky Way, but everything is going around the Milky Way, so you don't feel that. Similarly, everything is expanding rapidly in the universe, so you don't feel it. It's an inertial frame, even though you're expanding at the speed of light. Universes can go faster than the speed of light. It's the only thing that can go faster. So let's take a look in this scenario at a typical slice through this expanding energy sphere. And although I'm idealizing it as a line, it's actually very, very thick. It's a shell in Newton's theory, but a very thick shell. If you examine then, let's say, this chunk, and we'll take out a chunk, it's actually a very big chunk of universe there that's represented. It's like a balloon but with a very thick edge. When you look at the balloon, it's actually hugely large. So if you look at the forces in that area, on the inside, now this is where you need shell theory. Shell theory was worked out by Sir Isaac Newton. And shell theory looks at what is the gravitational effect that things feel in a hollow shell. And most amazingly and interestingly, if you're anywhere inside the shell, anywhere, it can be right by the edge, right in the center, anywhere inside the shell, you feel zero gravity, zero. But if you're immediately outside the shell, then you feel the full weight of that shell directed in towards the center. So one step and you go from 0 to full gravitational. In this expanding sphere, our energy band of universe, this is the outside of the universe, and this is the inside. On this side of this expanding sphere, the gravitational pull is 0. On this side of the sphere, the gravitational pull is the whole weight of the universe pulling you back. So you have a huge amount of gravity pulling you back. And this is a force that's along the sphere at all points in the sphere, at all times in the sphere, at no point. So what happens is, if let's say we're Earth, and we're right near the edge, and we send out a light beam trying to escape into what we call outside the universe. That light beam, because of this incredible force of gravity, literally gets bent back like this. Light can never escape our universe. It's always going to be contained. Any light that's emitted that way gets bent back. Any light emitted that way gets bent back. This is exactly the concept that Einstein was describing in his little picture and description of light being bent back on itself. Let's look quickly at the implications of that and consider now, if this was the universe as a whole, we can look at this diagram. We can imagine the globe of the cosmic background radiation being a tiny thing in the center. If this is Earth here, when we do a map to try to picture that, we're here. We look in every direction to try to see that. But because of this field setup, when we're looking in this direction, the light gets bent back and you're actually looking at that. And that's why if you were here and looking this way, you'd see it. But if you were here and looking this way, the light gets back and you'd see it again. So no matter what direction you look in the universe, you're going to see a little bit of this. And not only that, but every other alien in the universe, if they did the same experiment as us, would be looking back at this from a different perspective. It's as though everybody in the universe is inside a synsphere. Everybody's equal in this universe. And everyone looks out and maps the same thing from this universe from a different perspective, because everybody in the universe is somewhere in the thick sphere, never able to escape it because of this intense gravitational field. Just to quickly add in how spiral galaxies were formed, if you can imagine in the thick sphere, you had clouds. These are the clouds that you see here. These are the early galaxies. In each cloud, only 3 things were created by the Big Bang. You have hydrogen, you have helium, and you have dark matter. The key thing here is that these clouds were thrown out so that they all had coherent angular momentum. That just means they were all spinning. In a field like this, with spinning hydrogen, helium, and dark matter, all initially thinned out and spreading randomly, but all coherently, because of accretion disk physics. Accretion disks are the great organizer in the sky. The rings of Saturn are accretion disks. The solar system is an accretion disk. All types of stars, including black holes, have accretion disks. And what happens is, in normal physics, when something's circling around something very dense, it gets accreted. So all the hydrogen and helium, although initially distributed more randomly, starts to accrete to a disk. So these undifferentiated balls start to accrete to disk. This is all the matter forming the spiral galaxies here. The dark matter, because it doesn't experience friction, it does not experience the electromagnetic force, will never accrete. So the dark matter is continuing to spin its merry way, but it has spun a spiral galaxy. So to summarize very quickly, we have the Big Bang creating energy. The momentum is the dark energy, if you will, propelling this energy band and a rapidly thinning energy band out at anywhere from 3 to 10 times the speed of light. because of the nature of the energy band and using Newton's shell theory, you can show how very easily all the light gets bent back on itself, showing you why you can see this baby universe anywhere you look in the sky. Theoretically, there could be other universes, and theoretically, universes could bump into each other. Universes could merge, just like galaxies merge. Because of this incredible gravity pulling everything in, universes until their very last stage are going to appear black because no light can escape them. So it's theoretical that we could be right next door to another universe and not see it because no light could ever escape it. I call this the big shell theory because so beautifully it ties together Sir Isaac Newton and his development of a shell theory. The universe is a big, rapidly expanding shell. If we look at the universe right now, if this was the size of the universe when it was 380,000 years old, 10 times 10 to the 6, the present universe is sort of like that. Across there is now 10 times the radius, and the whole size of the universe is now 10 times 10 to the 9th. So that's 10 billion. Here's every single alien anywhere in the universe that's going to look back and map the same cosmic background radiation. Globe as us. Locally, any person in the universe, an alien here, can only see this much of the universe in this direction. But in other words, in the adult universe, if I'm the adult universe, this fingernail can only see that fingernail, and that fingernail can only see that fingernail. So you're never going to see the rest of the universe. It's just too big. But everybody, that fingernail next to that fingernail, that toe next to that toe, will all look back and see the common baby picture. We all share our common baby picture. After all, we are all of the same mother, the Big Bang. My name is Romeo Bruni. I hope you enjoyed this. Have a great day.